It's a Thursday. Be back in coding. Just like I said at the end of last stream yesterday, we're gonna make this feature work. Happy Thursday. What's a way to say happy? TH, thankful? Is that happy? Thrifty. Thimble. It made me laugh. Thick. You just cut it with a knife. You just cut the happiness on it. Anyway, what we're gonna do today is on Tuesday made a feature in Switchball Deluxe such that when you hit the little flowers, which again today we're gonna make them actually look like flowers and put them in the game, pollen goes poof. The functionality of actually changing the blocks around everything, it all works. It's all done. But the visual effect is what we're working on. So we need to add a visual component to what's going on for gameplay. That's what we're working on. So the visual component needs to show that the pollen is exploding in the right radius and the right speed, depending on how big the poof is from you hitting the flower. That's what we're doing today. So, what we're going to do first is show what we have this far. Then we're going to put in the flowers. So we're going to put in our art that I made that I like to call NT, not terrible. And then once we have the NT flower art in, then we are going to do a lot of probably like trial and error until we figure out how to do the right radius. And eventually maybe trial and error might not work. We might actually have to do some math. What we're looking at right here, there's an update method in the pollen class that is moving the position of these particles of pollen in a circle, a circular motion, sweeping, spirally, circly motion. And first, though, why don't we start the game? And we're gonna have to do starting up the game multiple times. I have to be able to find somewhere in here where I can turn down the audio. I keep turning off the audio because when we're developing, I'm just using music background. So, we can just go to the menu, and the menu controls the audio. And then that'll tell me where the audio is. Theoretically. Controls menu. This is the way to do it. Okay, so we're gonna go to audio. And then here we have an audio controller. It's audio control. Music volume. Oh, so what if we go to that method? This is in the audio control class. And here you go. The default volume is 0.5 for sound effects and 0.5 for volume. So for right now, we're going to make this 0. And we're just going to do this. Because I'm tired of going and turning off the music every time we start up the game. And this class is located where? Right, inside our audio folder. Okay, let's boot it up. Hey, it worked. No audio's playing. Alright, need to change the game to show this, because yesterday we were playing our Ocarina of Time practice ROM. This one. Yeah, I'm gonna make it smaller. Beautiful. I can actually go in here and show that it's at 0. It worked! Wow, incredible. Okay, so we're gonna go to the biofuels world, where all these are located. And we can go to any one of these levels. We'll just choose reticles. And start it up. So this is what we have this far. So those things in the middle are pollinators. So when we hit them, you can see that we have this really cool spiral effect going out. And if I increase the combo level, even more are spun out. Now, the time that they're spun out and the radius that they're spun out and everything like that right now is the same no matter the combo level. So one of the big things is that the combo level, as it goes up, it needs to increase the radius, not just the number of particles. And the radius that it goes out is going to need to be equivalent to the color. So here you can see that as I go over here, see how it's immediately turned yellow? If I go over here, these two. So it's going to need to be way faster too. So it's definitely spinning circular wise, like in a circular motion really quickly. You can see how quickly they're moving that around the circle, but they're not moving radially out very quickly. So we're going to have to change the math formula so that it's more of like one of these things rather than necessarily a circle. That looks pretty cool. So there you go. That's what we have this far. Not bad. So what we want to do is we are going to put in our flowers. We can close the game. And we're going to show GIMP. So here is our object sprite sheet. You can see here are the objects right down here. So the ones we were dealing with. And we're just going to put our flowers right where these guys are, these locations. I'm actually going to resave this thing with a background. So we're going to add a layer. I'm going to call this background. Or grid. We'll just call it the grid. Which is the same size. Ooh, this is a funky song. Why don't we choose a color? I generally like to choose cyan for my grids. And then up here, there's an option within our tools. None of these will open up on stream. It's just the way it is. Once these drop down show. But what we're going to do is, we've done this before, where we are going to, oh, it's a filter, never mind. Filter, render, pattern grid. And it's going to be a 16 by 16 grid. And it's going to be 1Y. And that helps us see the location of all these different items, these different sprites on the grid. these actually over here were as a reference. So these actually aren't on the grid. They're not being used. You can see that they're actually not on corners. So we're going to go ahead and save this. And I'm going to put that right there. And now we're going to put our flowers in place of each of these 7 sprites. So we have 2 flowers already. It's over here. We have an orange one and a green one. So we can go ahead and bring these over. Let's copy. And we have plenty of space over here. Let's put them right here for now. So we need to make 2. We need to make 5 more of these with a similar color scheme of these 3 colors. So we're going to make a white one, blue one, yellow, red, and so yeah. So we can just take this. Now, there's a couple different ways you can do it. One, you can do a color swap, which is a thing where you can take all of one color of an object and swap it with all of another color. You could also just color in the dots. What are we feeling? I'm feeling color in the dots. So you could just use the bucket tool. Markers right here. And you just color in the dots. So this is going to be our blue one. Now this is more of a blue-purple. It's kind of just the color scheme for this color. Especially the outline. And we're just coloring in. Look at our beautiful color. Now it's blue. And we'll take the secondary color, which is this one. It's right there. Go back. Paint that in. Scooby-Dooby-Doo. Nice little, just follow the colors. And then our last one is this blue. There we go. Bop, bop, bop. And now we have a beautiful blue flower. These were based off of poppies. Found a picture of a poppy and made that. Pretty happy with it. It's a decent NT Josh art. Claus art. Josh art, Claus art's the same. Spoiler. Okay. Take this color. It's kind of a mustard yellow. There's a very fine line between mustard and gold. Like that is, apart from the yellow, that's brown, you know? Like when it has yellow around it, it even looks mustardy. That's definitely a brown. Like 100%. It kind of fits with this color scheme here. And we get this, and we'll make it all like this. Boop, boop. Ooh. Sometimes I like doing monkey work because it's satisfying just to do it, you know? You just gotta see it come together. Don't need to be ruthlessly efficient. Oh, look at that. Pretty yellow flower. Let's do the red one. So we're gonna go this one. I'm gonna get the maroon. maroon. If you zoom in too much, the little grid goes away. And then it's blinding. It's a nice wine color. Very good. The next one is a brighter red. Zoop, 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 zoop. And then we're gonna fill in the rest with this pinkish, cloudy pink, pastel pink, salmon. You can call this salmon. There we go. There's our red one. Let's move that a little bit. And we're gonna put another one down here. And this one is gonna be this cyan assortment of aquamarines. I think of all colors, aquamarine might be the calmest color for me. I mean, serene, kind of like an aquarium. You know, there's a certain serenity to being in an aquarium. It's like what the color feels like to me. Alright, I'm gonna grab this color. Fill in the other lines. Doop, 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 but doop, but doop, but doop. And then the last color. All right. So there are 6 colored ones, and then we're going to need our white one, which is kind of our inactive flower. Like that. That's this one over here, series of grays and white. Sort of blending in the background. It almost looks right already, but cyan needs to be a white. Over here. I don't think this is pure white though. It's definitely a gray. Okay. There are 7 flowers. And now we're going to substitute them in these spots. And we have the lights here to designate this is kind of where the colors are. So we do not need these anymore. I'm going to take them and say if we ever need thee, we can find thee in source control. Boop. And take that one. It's going to go over here. Let me get that green one. bluey slash purpley. Such this fine line. It's got purple hue. Here's our orangey one. Here's our yellow. Our red one. And our cyan one. There we go. There are flowers. Very cool. So we're going to go ahead and save that. We're going to hide the grid, and then we're going to export this file back to its PNG. Okay, so we have our new file. So one of the things I want to be able to show is the one of the main parts of Monogame is how the content pipeline works. So the content is driven by all the sprites and all the sound and everything that's like media. Is you import it into a pipeline tool. That pipeline kind of, what's the word? Makes it smaller, compresses it and stuff. And then the game speaks to that compressed instances of the stuff. That's a great explanation. So we have this sprite sheet. Now, I'm not going to show Windows Explorer, but I will show the pipeline tool. So if I go to Visual Studio, well, actually, we're going to need to go to the project in Windows Explorer. And then once I open up the Monogame pipeline tool, I will show it. Okay, so now I have the window here. So let me go ahead and share that so I can show it. Okay, so let's Monogame. Where is it? Is it this thing? There it is. Cool. Alright, so here's our pipeline tool. Looks pretty basic, right? Little window. And this is the content of our project. We have fonts. We have these TTF fonts, which are true type font files. Music. We have some levels, sound effects, sprite sheets. We have some video files. We also have these bank files. These bank files are the files for music. What's it called? The big one. Wow, I'm skipping on the name. Where is it on here? They're music bank files. I forget the really common music integration name. Oh no, now I'm skipping. Music bank files. Where are they from for games? Fmod. Goodness. Couldn't remember Fmod. So that's what they are, and they're sitting out here. So what we did is we made a change to our sprite sheet. So in here we have our sprite sheets. Let's open this up. Can't really zoom in, so it's just the way it is. No, just I think it's big enough. You can look at the screen. Put your eyes closer to the screen. There's a few different ways to do this pipeline tool. Now the way I do it is probably not the most efficient. It's pretty manual. I bet there are ways that you can like do stuff more better. But we have our sprite sheet that we just updated, which is this platform object one right here. I'm actually going to remove it from this project. I'm going to go to the content itself and remove it from there too. So now it's gone. However, we save all our sprite sheets in a different location. So now that I've removed it, I can go here. Can't see the pop-up, but there's an option to say add an existing item. So this existing item is where we just saved our updated spreadsheet. So I'm going to go to there. It is in my drive right here. It's great that you can't see this, but whatever. I'm selecting a file. I am opening the file. There's a pop-up, and you say I'm going to copy the file to the directory. And now you can see it right here. Now there are these different actions here. You can say build, texture importer, all this stuff it knew how to do correctly. There's probably some setup I had to do for different files originally, but for this PNG file, this is all correct. And then we need to build. So we're going to go up here and build. On the right, you can see everything else was already built. So all it needed to do is build the new file that I had. So you say it says built 90 succeeded, 0 failed. So just like a project is built in code, these Monogame pipeline builds like a little project that has all these files in it. So now it's part of that. And that is automatically tied and it's within my game. So that's all we need to do. It's there now. So we're going to go back to the game. We're going to boot it up and we're going to show that the flowers that we did are now in the game. And we can test all the colors. So we're going to hide Visual Studio. And let's go in here. Why don't we choose a different one? Dust Piercer. Whoa, that looks so different. Look at all the flowers. That's sick. Let's see if they change color. Alright, so they're yellow now. Very cool. Now, it would be even cooler if we had like some sort of animation of them kind of going poof, like a little poof. Kind of like when you hit it, it would go poof, like a little poof. But right now we're going for NT, which is not terrible. That'd be even better than NT. So we already have 3 colors here in this level. Let's just go ahead and add a couple colors just to flesh it out so we can see all of them. So we'll go ahead and add our orange one, our cyan one, and our green one. Uh-oh. We don't have unlimited time. There's green. Cyan. We're gonna explode. No! Let's try it again. You know. This level had times associated with it. It's been play tested. Okay. Oh, that's cool. That's interesting. So if you don't have a color, it's doing the pollen, and it should not do an effect if you do not have a color. So that's something that we need to change to. So I'm cyan. Doing cyan ones, which is great. Green. Just doing these green ones. And orange. Beautiful. Cool. Great. Alright, so it's working. The thing that I mentioned is here, if we have no color, we don't want any pollen to go out. We don't want any effect. So right now, so it's doing a default effect. We made it blue was the default. So if we don't have a color, we don't want anything to go out. And that's just going to be another check for when we hit it. Say, hey, only show this animation if the player has a color. Because that's not good. Alright, so part 1 done. We put in our flowers. Why don't we play a level? It has a bunch of them. Wave shift. Oh, look at that. Looks so different now that there's actual flowers. This looks great. Oh my gosh. Visual effects is so cool. It's gonna look even crazier when we actually get it right. I don't think I have a time for that. There's no way that's actually, those times are correct. Well, maybe. I don't remember. The fact that I almost got S rank and I was just kind of goofing around. Maybe I just did it real good. Okay. So now on to the actual thing, which is making the radius be the size of the combo, making the animation clearer and faster. And then the first thing we're going to do is fixing it so that if you hit a flower and you do not have a color, nothing happens. Nothing is happening functionally, but we also don't want an animation to happen. So we can actually just pause the code. We're going to go ahead and do this, which is essentially a command prompt pause in the game. And why don't we show Visual Studio again? And we can go over to our pollinator here. And what we're going to do is we are not going to generate any of this stuff if the player's color type isn't a color type. It's interesting though that this is actually doing the change color method, but because the change color method is attempting to it's only actually working in this if statement. So once it gets here, it's saying, hey, if the color type is any of these, the actual color types, then change the color. But we're actually going to prevent it now from even going in that method, just right here. So what we can say is this. I should probably pause the code. We can just say if color type is not equal to color type dot none, go ahead and do that. So now I won't do it anymore. We actually don't want the, well, we probably do want the sound effect still. Maybe it'll be a different sound effect, but we're not at that point yet. Why don't we just press continue and see if that worked. So now, if I do not hit a color, it does nothing. That's what we want. It's not activating anything. But now that for a color, it does the thing. Beautiful. So that was a super easy, super easy fix. So we're gonna stop the game. And we're going to choose a new music mix because I think this channel is done. Let's see. Yeah, sure, why not? This guy. Just all right. So the first thing that we want to do is I want to change the speed at which, so the speed is going very fast circular motion, but we also need to move it out faster that way, like an expulsion. And when we're creating the pollen, which is happening here in the pollinator, this is what we are passing in. We're passing radially. Where is the pollen starting? So we have a circle, and if there's only 5 pollen, because it was at a combo level of 0, we're spacing out the pollen starting points according to the number of pollen there are. So the more pollen there are, we're starting them out at different spokes of the circle, the wheel, so to speak, because they're going to be shooting out from the center of the object. That is the launch segment. However, we're not sending out anything else other than launch segment right now. So we probably are going to need to pass in is the radius. How far is the pollen going to move? Or we need to pass in, or we need to pass in a speed. So that's what we're going to be thinking about, is how we're going to do that. First though, right now what we have is pollen that kind of shoots out and then it just spins for a while at a certain radius, rather than something that's more of a curve. So let's take a look at what it's doing. The different variables that we have right now are here. We have a circular speed, a radius, we have the origin, we're actually not using this right now, and we have a launch angle. And if we scroll down to our update method, this is what it's doing. It's saying, how are we going to move? So we're adding to our origin x and or origin y, and we're using a curve. We're using a cosine and sine curve with a radius. So this is a radial momentum. And then it says if we've moved, which I'm not sure why we have that if statement, but this came from another method. Our angle is adding to the circular speed. And here, if we are getting past a certain point, we're resetting our launch angle. So it's all of them are starting at a certain launch angle, and it's constantly moving through, increasing the angle as it moves along for this curve. So we're kind of going at different points along this cosine and sine curve as it's moving along. That's all well and good. It sort of works fine. However, I'm not sure right now visually how it's changing. I think what we need to do is we have a radius here, and we are adding to our radius each frame, we're adding 0.52 f to our radius. And I think this is the first thing that I want to test, is how does the rate of change of the radius of the circle, because naturally if you change the radius quicker, theoretically the circle is going to get larger. At a quicker rate. So we're probably going to need to change the radius way faster. And then right now, in the pollinator, this is dictating how long the effect stays out. So right now we're doing the effect staying out for 2 seconds, mainly so we can like see what it looks like. But it's going to be likely a very short period of time because the effect is instantaneous. I'm not making the animation dictate how quickly the bricks around the pollen are changing color. It's a very fast action puzzle game. So when something changes color, it needs to happen instantly, which means this is almost going to look like a flash, but it's okay if it lags a little bit behind. Kind of like freeze frames, you know? It's alright if the effect is just like a little bit slower than the flash, but it needs to be somewhat close to it. So this is what we're working with right now. How about we first change this, and we're just going to make a nice even number. I'm going to say 1f. F means it's a floating point number. So we're adding a floating point number when you put f next to it. So we're just going to save that. And this is the class where we're going to constantly be updating and changing our radius. Our radius starts at 0. Our degree launch angle is given to us. And our circular speed right here, we're just setting at 0.3. This is something that we can also mess with. So we're not changing our circular speed. It's just how quickly our launch angle is changing as it kind of spirals through. So we're just going to put this down here as well so we can modify that if we want to. And start it up. So first we're just going to do some trial and error. We're not going to try to do all this math and stuff yet. For it to be perfect. And why don't we go to a later trip? Any of these I don't have are in pollen. I think some of these I don't have times. Yeah, this one I don't have times. I can count. Do you see it? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's try this one. I kind of want a test level. Yeah, why don't we actually just do this? We're going to restart the game. And let's go to our constants class. And we're going to scroll down. We're going to be doing the test level here, so we're going to be changing just the first level of the game. It's pretty empty space, so we can test in there. This is all I'm changing right here. I'm just going to put another one, comment it out. Oh, come on. And all we need to do is just make sure the time is infinite for how long the level is. So here we can just put like a bajillion seconds. Wait, why isn't this... This looks so weird. Is this actually commented out? Yeah. Visually it was looking weird. So we'll use the first level as our test. Oh. Okay. Here we are. So now we have infinite time on the clock. And we're just going to go ahead and put in, delete a bunch of these, and we'll put in some flowers in the middle. Just put some blocks up here so it level's impossible to complete. We're going to go to our object. And where are they? Oh, they're over here. Cool. There's a flower. There's another one. And another one. I'll put some other blocks here too. Yellow ones, why not? So, this is going to be largely trial and error. So right now we have a radius of 1 and a circular speed of 0.3. So when I hit this guy, Wow, the radius really helped. So it's 2 seconds. The particle we're using right now, you can see it looks like a little bit weird. If we open up GIMP, show GIMP, I decided to essentially just take a chunk out of each of these colors. It could be a flat color, really easy to modify, but that's what we're doing. So it's has a hint of each of the colors, and it's just a 3x3 little rectangle is what's going on. So right now this is a radius of 1 for 2 seconds, and it's kind of spitting out. Now, this isn't very helpful if you can't see blocks being transformed. So we are going to take some of these blocks like that. These are red. And we'll add some green ones over here. And we can see them go back and forth. So now if I hit this, those get changed to orange. You know, and if I wanted to make it green and change them like that. So it still isn't fast enough. And you can see it does reset if I hit it again. It's 2 seconds. It's way longer than it will be. But despite it being pretty fast, it's still not nearly fast enough. It needs to be like zoom, zoom. Now, if it was just a 1 brick radius, because right now with our initial combo level, it should only be going around 1 brick. And at 2, it'll go around 2, and 3, and 4. The speed might be sufficient, but it's way, way, way too slow if we were going to do, say, 5 or 6 or 7. I also kind of want the speed to increase exponentially rather than statically. Right now, it's doing that at a constant rate rather than an exponential rate. Hey, what's up, Nick? So if we go to the code and show it. So here we're increasing the radius at a constant rate of +1f. If we want to do something exponential, we could do something like an exponential function, like radius equals radius plus radius squared or something like that. The other thing is the speed at which the stuff is getting expulsed. So is 1f even fast enough for the stuff to get expulsed? But what I think I want to do is do some math. So this is how we're going to do the math. It's actually not going to be that hard. I'll explain what we're going to do. First, let's look at GIMP. This comes context. So we'll go here. This is our little playground. So let's go ahead and delete all this garbage. So let's take a flower. And think about the particle effect. So we're going to have, let's just do, I don't know, bright color. So for our first combo, this flower affects all bricks within a radius of 1. So by default, its radius is this wide. So all bricks within this radius get changed to the color of the flower that you're hitting. Then, once you get the next combo, it does a radius of 2, so it extends this far. And the same for radius of 3. So every single time, it's going out one further. And then of course radius 4, all the way up to 10. The max combo is 10, so theoretically, I don't think there's any levels that actually extend out that far. But if you get your combo level up some of these, it is pretty crucial. And then one little bump on this pollen can send it way out and change bricks this far away. So let's think of the distance between the center of the flower, and I'm just going to add a new layer here. The center of the flower to any given particle that is being sent out. And we'll use red for this. So this is a 16 by 16 grid. So this flower is a 16 by 16. It's going to have a 16 by 16 block above it, one to the diagonal, one to the left. So if we can look at the game, is the game still running? Yeah, the game's still running. So you can see this brick right here, it's affecting the bricks around it. So if I, for example, put blue bricks, it would affect these blue bricks with a combo of 0. Once I get a next combo up, it would affect all of these bricks. Each of these bricks is 16 pixels wide. So you can see that the total distance that the particle would travel, if it's the very center of the flower, it all starts right in the center, would be 8, because that's half the flower, plus 16, so which it's 24. So if we pause this again, go back here. So then we can say that the distance that any particle would travel if it was going strictly horizontally would be 24. Now, if it was going, say, in a spiral motion, radially that's very different, right? It would be traveling like in a spiral and be doing way more than a strict 24 pixels of movement. But our goal is not to see how far it's traveled. We're trying to see how far away it is from the middle of this flower. So for example, if we had one that was 24 here, if you added another 16 to it, it would be 40. Suppose the second would be 40, then it would be all the way to 56, 72, etc., as it keeps going out. So our formula horizontally and vertically from the middle for how far away a pixel is in terms of reaching the edge of the effect is 8 plus 16 times however many rows we're out. So what we can do is, rather than using time to determine whether the pollen should go away, we can determine the distance that the pollen has moved. And then we can pass in a given speed depending on the combo. So if we wanted the combo at a higher level, say like 4, to be at a higher speed in order to show that the explosion is that much more explosive, all we have to do is put in a higher speed, and then once the pixels reach a certain distance from the center, they'll go away. So that's the plan. So what we're going to do is we're going to go back to the code. Right here. And we're going to go to our pollinator. So right here, we're doing everything based off of this pollen start and end time. And that's what we're going to change. So we're going to go ahead and stop the code. So what we said is the distance between any pollen object and the flower pollinator. Am I gonna keep? I'll keep spelling it wrong like that. Although, isn't is a pollinator an actual word? I think it's made it up. I think it's an actual word, right? I'll look this up. Pollinator. No, I did spell it right. It's with an I. A pollinator is with an I, and a pollen is with an E. See, I must have looked it up. I know what I'm doing. English is weird. So, distance between any pollen object and the flower pollinator is 8 plus 16 times the number of the combo, really. And it's the combo plus 1. Why is that true? This is because at combo 0, the default is changing 1. Is radius of 1. So that's kind of our formula for how far any given pollen object or particle would need to be in order for the pollen to disappear and to get removed from the collection. Now that's not perfect, because at the diagonal from it, it's a little bit longer. Just like if you had a square and it was a, well, yeah. So if you had a square, let's go over here. Let's make a square. So if you had this point on the square right here in the middle, this distance and this distance, assuming this was actually a square, is the same, but this distance is not. Why is that true? Well, say you had a unit square. Say this was 1 and this is 1. Then what is the radius? It's 0.5. You have your little triangle here. Right? Boop, boop. It's 1. It's 1. So a squared plus b squared equals c squared. Right? So 1 plus 1 equals c squared. So 2 equals c squared, which means that this line is the square root of 2 in a unit square, which basically means that half of that, this right here, is root 2 over 2. So the distance from the middle point would be 0.5 because it's half of 1, assuming we're using just a unit square, right? Whereas the diagonal distance in that case would be root 2 over 2. They're not the same, right? The square root of 2 is not 1. So the diagonal distance is slightly different. In our case, though, as this is a visual effect, we're just gonna not think about that. We're just gonna say that the particle is out this far as it's moving, good enough. And I think visually it's gonna happen so quickly that the difference between this distance and the vertical distance is gonna be negligible with the speed at which the effect is moving. Okay, so this is what we want to do. So how do we do that? So of course we're going to be just updating them. So this is still true. if the current pollen exists, if there's anything in this list, continue updating them. And this is what we're going to be doing. So I'm going to do this is we can take out everything here. So we're just going to go ahead and take out all our hard work. It's going to update it infinitely. Well, the magic is happening in each individual piece of pollen. So now we're going to put this in the pollen class in this update method. So we're going to do, just slap this up here as a reminder. And each loop, as this gets updated, we are going to check the distance between the pollinator and the pollen. Now, right now, this piece of pollen is agnostic. It doesn't know that this guy exists. So this pollen is going to now need to store the position of the other guy. And I sort of lied. Why did I lie? Because we have the original position, the origin. So the origin is where it's starting. So we can just use the origin and say, hey, how far away is the origin from our position? And that's how we're going to do it. And then we're saying if we're far enough away, we can either remove itself, which is probably not what we want to do. We probably want a flag that says to be removed or to be deleted or something. So as this loops through, instead of doing a for each loop, we'll use a for loop. When you're removing objects from a list, if you're doing it in a for loop, it won't explode. If you're doing it in a for each, it will. So you could technically do a for each and then a for loop afterwards to check if there's any that are to be removed, which is probably what we're going to do. So you can have a flag that says, hey, delete me, or out of range, or something like that. So we'll just create that. We'll just say, hey, we'll create a public pool. And we're going to say out of range. So here's our public pool out of range. By default, it starts false, but whatever, we'll just say false. It's redundant, that's fine. So what we're going to say is if, I don't know, blah, then out of range equals true. So what is the blah? The blah is this. We have to find our distance. So what is our distance between the x and the y coordinates? And here we can actually do some math again. So we can use the distance formula. What is the distance formula? I'll show it on screen. We're doing math today. He says he wasn't gonna be a math teacher, but he's doing it anyway. All right, distance formula between 2 points. All right. The distance formula, let's just show this, is the square root of x. Here, I'll just write it. Down here. I'll make sure to make it slightly, slightly better. So d equals the square root zoop of x2 minus x1 squared plus zoop. And you thought you'd never use this. Until you do game dev. And you're like, oh, I need to learn math. What? Okay. That's the distance formula. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. So we're going to use this formula to find our distance d. And if d is greater than our stuff that we defined, the 8 plus whatever, then we remove it. Okay? That's our plan. So, we'll just do it in pieces. So our var x total is our x2 minus x1 squared. So what we can do is, what is x2 minus x1? Well, our x2 is our position x. So it's going to be our position dot x. And our origin dot x is x1 minus origin dot x. Then we're going to need to square that. So there's a couple dozen ways you can do it. Easiest way is to go like this. Because we're just doing a squared. You do it like that. You can also do it like this. And there's a math function. Math dot expo. Oh no, that's e raised to the specific power. Math dot I don't know. It's one of these. Yeah, there's a math dot square root. We're gonna have to do that. All right, that's the x total. Then we need to get the y total. The y total is y2 minus y1, and we'll square that. And then the distance is once we change the music, because our music stopped. That's a good channel. Good job, bud. Beat the boss, beat the blues, late night beats. Ambient beat, vintage beats. Sure, go for that, baby. Why not? No, this one. There you go. Make this slightly less. There you go. So then our distance is, we said it was the square root of one plus the other. So we're going to do math dot square root of x total plus y total. That's our distance between the 2 points. Now you could do a function if you wanted to pass in these positions. Why not? We did all this work. We can also show how to create a really quick method, just for funs. If we were going to use this outside of, in games, it might be a common thing to find the distance between 2 points. You'd probably put it outside this method. right now, I don't think we have a need for that. So we're just going to put it in this method, or in this class. So we're just going to do a public, this is going to be float, get distance. And we're going to pass in the two vectors. Vector 2 are 0.1 and vector 2, 0.2. So our distance here, we'll just do this stuff and put it down here. And we're going to return distance. And these guys are just going to be our points. So 0.1 will be our endpoint. A double. Oh, square root's get a double, not a float. Whatever. Give us a double. So this is a get distance formula between any 2 points. Neat. So then we'll say var distance equals get distance. And we can just pass in our position and the origin. And we're going to say if this distance is greater than this. So this guy is our max distance. It's this. Where the combo happens to be the player combo. Plus 1. So this is what we're defining as the max distance. So we're going to say if the distance is greater than our max distance, then we're out of range. Move this stuff down. So there we go. We now have a way of dictating how far the particles ought to move to be out of range. So we're going to set this to true. So let's go back to our pollinators. We don't need to have this here. So it's going to continue updating them, and eventually they'll become out of range. So then we're going to do a for loop. And we're going to say if current pollen at I is out of range, we're going to do a current pollen dot remove current pollen of I. So we're first going to look through all of them. And then after we're done, if any of them happen to be out of range, we're going to remove them from the list. Eventually, they'll all be gone. And then eventually it'll be very quick. Pop, pop, pop. So now we can try it out. We already know that these guys are moving a lot quicker. We saw that they're going way far away. But what's great now is they're just going to go until they're removed. Theoretically, assuming this works. First try. Let's try it out. Okay. first level to test again. And we're going to wheel on our flowers here. So remove all these. Okay, so we're gonna get our flower objects here. We go 1. Now let's put some different areas. And why don't we get some different colors in here? We get some red, some yellow. We're really assuming this is gonna work, huh? Okay, and why don't we have some cyan to change colors? And we can always put more in. So let's start it up. Okay, so we're yellow. We go boop. They went away. Look at that. Pretty good. And it looks pretty close to the radius. So why don't we put in some more blocks to see that? Let's do it like this so we can really see the radius of it. So we're going to go ahead and get red. And you can see it's basically spinning out as it covered red. Pretty quick. Now if we wanted to be more dramatic, and now here, is our combo up? It's going way further. I don't think so. Now we're at combo level 1. Whoa! I think our formula is wrong. That's going way, way further out. I think for every single brick that I hit. Oh, I'm doing combo. I'm not doing my combo level. Every single brick that I hit, it's going out further. My bad. Why can't we ever get things right the first try? Oh, so simple. Instead of the combo, which is literally counting 1, 2, 3, 4, 5 every single time you hit it, it's just the combo level. My bad. Alright, now it'll do the radius of 2. Very nice. And let's take a look at that. So let's go ahead and put some bricks back in there. And we'll see it kind of reach there. So yellow. Boom. Oh, we broke our combo. So now it's only 1. That's accurately. Darn it. I'm gonna get my combo up. Alright, now we're at a higher combo level. Oh yeah. Pew! So you can see it's basically getting to the edges of it. And in the corners, it's not quite as we predicted. So if we wanted even more dramatic, you could make the, one, it's going to need to be a little bit faster. But might need to make the particles bigger too. So now it's combo level 3, so it's going shoot to 3. We can get up to 4. Now it's 3. It's going to be a 4. Yeah, it definitely needs to be a lot faster. But the radius is perfect. Oh. And now just for funds, because we can, we just put a whole bunch in to make it pretty. Look at the fireworks going off. Okay, so we did it. we now have the radius being related to how far and big the combo is. And our next step is going to be changing the speed based off of our initial combo when we're hitting it. That's what we want to do. So let's do that. We might need to stop the code for this. So we want to say that if the combo level is greater, that the speed is faster. And yeah. And it's probably at the point that you're passing in the object. Like we don't want to, I mean, I guess theoretically this could happen. You could hit a block, then your combo immediately increases, and then the animation of the initial explosion changes. That doesn't make any sense. I don't know, it's a visual thing. But really, this. We want our radius increasing at a rate that is higher if the combo level is higher. Our circular speed could also increase, but that seems less important. So how do we want to do it? Right now we see a radius of increasing at 1f every cycle, every update is somewhat quick. I think it works pretty well for combo 0. Still, I think it's not quite fast enough. So why don't we increase it by an additional 0.5f for every level. Something arbitrary to start. So here we'll have 1f, and we're gonna say it's 1.2. Just to make it faster. And we're gonna say plus. Add something to it. It's gonna be very similar to this. Instead of 16 times this, why don't we do 0.5? See what that looks like. Oh, that's fast now. Pew, 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 pew. And now if we break combo, it should be a lot slower. I mean, it's still quick. Let's make sure that it is correct. So go in here. Put a little one of those in. And oh, this is our rate of change. Yeah, let's go ahead and pause this. We're going to reset it. I want to set a variable here. Var rate of change. So we can take a look specifically at this. Our circular speed could also change based off of the rate if we wanted. I don't know. Why not just let it update? I guess you could do this too. We didn't need to. Do that. We'll make it a lot less because it's only 0.3. Like that. Okay. So now we are changing the rate of speed change. We can tell based off the radius. We have our circular speed. One of the things that, because it's so much faster now, I kind of want it to be bigger. Or I want there to just be more particles exploding out. So why don't we increase that by a little bit? So we're doing it right here. Why don't we just increase it to like 8? 8 plus 8 times. And here, even though we are doing 3 by 3, it should be position plus 7, so it's centered better as well over the middle. Because the x-coordinate lines up with the left side of it, so if we move it over a little bit, it's be right centered. Also, I think let's go and just make it a flat color. I don't think the color is looking as good by taking a chunk. So if we're going to do a flat color, what we can do is we can just denote a certain spot here in the y-axis, because I think x-wise it's fine. So it would just be like a 3 by 3, like if we just took it inside this light or something like that. So this right here is 502, 140 for green. So we're going to go to pollen, hide GIMP, 502, 140. So green, we'll say 502, 140. 502 or is it 582? Oh, 582. That makes more sense. $582, $140. And then each one would be 16 over from that. So 582 plus 16 is 598. And they're each gonna be 2 less. So 14. And why is the purple one all weird? 664. Oh, silly. So this will just be a flat color as well. Wow, I did not hide GIMP. There it is. Here's us updating. So now we have a flat color. We are increasing the number of pollen that's appearing. We are increasing the speed as our combo level goes up. And the pollen's automatically getting removed as the combo goes up. So everything is working. It's just whether it's fast enough to make it clear that and helpful that what's going on is actually going on. You know what? Let's actually just some of the levels and see how it looks. This is a red one. That was really fast. Holy moly. Oh. It's not even... It is doing like a spiral. Oh. It's kind of wild. Oh, look at that. You can even see... It's a little bit too slow still. I still want it faster. But you can see now that one makes sense because I can see the radius, but it's still a little bit too slow. And it does look funny how there's some on the edge of the circle that, due to like the wonkiness of the distance formula, there's like some that just go like a little bit further. It might also have to do with the number that I decided to do, 8. Interesting. Why don't we try to modify that? So we did 8 around the center. I want to do 9. I think we do 9, it'll be better. So let's do a little bit of fiddling. 9. And then I still don't think it's fast enough. So I'm going to have the rate of change be 1.4 at a base, and we're going to increase by 0.6. The circular speed of it spinning seems sufficient. In fact, it might even be too fast. But let's try this out. And we'll just go to the next level. Zoop. Increase our combo a little bit, see what it looks like. Taking our sweet time. Ooh, that's now like a 9. It's like a little... Ooh, it is fast. Every combo level has like some stragglers. Look at this. I go back and forth between the two. Look at that. Intended behavior. Bam. Next. We can do this part, which is fun. Go boo. And go sideways. Whoa, that looks weird. What's going on there? What's going on here? Wait, what is going on here? So radially, we can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 8 is weird, dude. Or 9 is weird. It's like Alright. Let's get the next color. Oh, jeez. Go over this way. That's interesting. Because it's just choosing... Oh, wow, it did it again. Cool. But weird. It has to do with the number of... in the... They're aligning? Alright, so what we're going to do here is we are going to go here and see what's happening. I just put a breakpoint in, by the way. So I'll show Visual Studio. The number of pollen we have is 63. Because 9 plus 6 times 9. So it's 7 times 9, 63. And you take 63 and you divvy it up between 360. Each launch segment is 5.71. So the pollen number, I times the launch segment, 5.71. Why is this weird then? Our new pollens. We can't see this, unfortunately. We're looking for I is 3. Boop, 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 boop. I just had a TV show just came to mind. So that's the launch angle. That's where we're starting. I wonder why some are congregating around the edges for 8 or for 9. Maybe we should just make it even 10. I don't know. I don't know. There's some math going on. Math is mathing right now for why this is happening. Math is doing math's thing. Gotta love it. Alright, let's modify it. 10. We doubled it. Well, at least we'll get a nice even decimal. Surely. Surely that'll make a difference. No, it does not. Why? What's cool is you can see the radius here isn't affecting. Like if I go blue, you can still see the radius. Well, the edges are kind of... Yeah, the edges are kind of messy once you get out there. It's definitely affecting things way further. than it looks. To get the higher combos going on. Uh-oh, our combo's back down to 1. It's not perfect. That would be a lie. But yeah, visually tricky. Let's think about it a little bit. Let's just take a little think. Take a little think here. So, Smoky Joe. If if we made the motion less of a circle, and we made the radius expand at an exponential rate, meh. Let's try that. I'm gonna try to make the let's try to make the circular speed less. See what that looks like. 0.1. Same radial speed. What does this look like? Let me just do this level over again. I'm gonna go over here. Oh, that's kind of what we want. It's more spirally. Ooh. Ooh. That's pretty. That's perfect. Look at the spirals. You see the spirals? The colors, Duke. The colors. Colorblind kid. Oh, and now it's just splaying. It doesn't even have time to circularize, which means we could just add more circular motion more drastically as it goes up. Let's try now. Oh. Oh, I think we did it. We tweaked it. We tweaked a tweak. We tweaked a tweak. So I like the 0.1, looks really good at the beginning. But what if we increased it by more as the combo went up? So instead of 1.02 or it would be 0.12. We'll just do like 0.14. Start it. Look at that. That's great. So pretty. Let's change it all to red. Ho ho ho. Oh, now it's doing the weird line thing. I honestly, no idea. So you can see them coming out in bands. I mean, it still looks cool. It's just a different sort of... It's weird that they come out in bands like that, but they are starting at the center. But as they expand, they kind of clump. Yeah. Interesting. Why don't we try a couple different levels, see what this feels like. Kind of was liking the, despite it not being quite circular. Sometimes testing is just, you just take your little knobs that you already have. Still. Little. Gotta do your little twist. Different level. Logo. Hey, it's my logo. It's not far enough to reach. Boop, boop, boop. Oh wait, this one's being timed. So now I can be like, oh, I see it. Bonk. Oh, that's pretty cool. Oh, you can even see the little dots here. I don't make them go away. What's even fun, you can see more of it if you go to the pause menu. You can see the last explosion. Look at that. Pretty good. Which one we haven't seen? Slither? Slither would be pretty sweet, the snake one. Make it green. Boop. You know what? This is starting to be enough. So the big thing is having a visual component, especially as you're first doing it. Like, I was able to play completely competently without even a visual component to it. You can just kind of play. But having that as well just gives you a little bit extra insight into what's going on. Go. Boom. Bam. Dope. See, now I can like see, I can see the little dots go out. I'm like, oh no, they're not big enough. Then I'm like, oh, that's big enough. And I go, bam. And I'm like, oh, it's not big enough. Cool. I think that's gonna be it. I think, what That's cool. I just like having a little bit more flash. Yeah. Certainly, we're going to make some tweaks. Pretty easy to do so now that everything's in place, but it's working. Good enough. So we're going to leave it right there. Winner. And we'll think about what feature we want to start next week. I think tomorrow will be an OOT day. Probably start a new randomizer in the morning, if not do a little bit more practice. We'll see. And then the evening, tentatively planned, continuing my archipelago with my friend Saribi. But thanks for all who tuned in today for checking out this development as this feature got built out. Yes, more OOT. And we'll be checking this out later on Twitch and YouTube. Have a wonderful rest of your Thursday. As always, love you guys. Jesus loves you too. Catch you next time.